Hello. Be right back. Let's do it. Okay. We are currently compiling LLHTTP, which is Node's HTTP parser. And we've got what we need in builds. And we're just going to copy it into our K1 project. So this is going to be let's document it. So we'll open our just file, and it's going to be build LLHTTP, which is going to be, I don't know, get submodule update, and then cd LLHTTP, npm CI make dot cp LLHTTP build lib LLHTTP.a to libs lib LLHTTP.so and .h. One minute. Check my phone. All right, welcome. As you can see, we're working on our own programming language here. It's called K1. We're trying to do some HTTP stuff in it. It's a systems level language, so we get to use all the really fast stuff. So now what I'm going to do is build LHTTP. Okay. npm CI did not work. So why didn't it work? npm CI. Yeah. What? Just build LHTTP. So we build it, and yeah, it didn't work. The CD didn't work. Why can't I, just file? YouTube is telling me I'm not live right now. YouTube. Let's see if that's true. Here it says I'm live. Let's do it. I think it might be wrong. I can see the chat now from YouTube, but I can't see it from my popped out live chat thing. And then on my channel, it says I'm not live. Oh, I gotta figure this out. The dashboard sucks. It's so frustrating. Oh well, let me just switch to the stream itself and I'll watch that, I guess. I can pop this out. Has you in there. Hello, ZSA2265. You think what might be wrong? What's up? Yeah, it's weird. I don't know. I guess you can't because what? I guess it's not meant to be like a full script. Yeah, its own shell. I'm fine with that. I don't think that needs to be multiple lines. Maybe it's fine. Yeah, thank you, Clinker. Glad I wrote these from the root directory now too. All right, we got goodies. So in the K1 project, oh no, tree is dead because I decided to submodule the thing. Whatever. ls libs. In the K1 project, we have our libraries go in here. We've got the header we can use to bind gen from. We've got the shared object for compile time shenanigans. The static lib. And this thing, lib_http server.a, which is, I have no idea what that is. And http server.o. What are those from? What? Oh, May 28th. I don't think I made this project. Oh, did I not pull too? Oh, it's from that old, I know what that is. Okay. Cool, just cleaning up a bit. All right, and what do we need to do? We need to go to like K1 itself and just make sure we're up to date. Yeah, I don't know how many compile time shenanigans there will be in this stream because none of that's going to play very nicely with running an event loop and a bunch of threads. But we'll get there. We do have the SO just in case we wanted to parse some HTTP at compile time. Maybe for testing. We'll see. We'll see if it works. I might drop some frames here while doing a big parallel compile. Let's see. No, it says 0, so that's nice. All right. Let's see what we can do. Let's get to the fun part. http.k1. So these were generated earlier. Let's make sure we can still generate them. So let's, we got to build the bindings generator. One more step. So one bind gen. Let's build. Now, this is new. K1 test this project. And we have bindings generated for a file and then compared. Exited with code 1 though, they don't match. Sad. I wonder why this is failing now. But the way that's achieved is when you run K1 test, we just set this global test to true, built-in global, and then you can do whatever you want. You can conditionally compile whole modules in, for example, if K1 test, all my tests. We can do an ns tests, and that won't appear except when compiling under test mode. It's what Rust does, I think, right? With the CFG test, most people only deal with the conditional compilation for tests, and then it annotates individual functions as tests, and each one of those are like their own main, so that each one can like panic and stuff. I don't have that. It just checks the exit code of the whole program. But what I did here is if it's test, and I wrote a function called test, which tests bindgen by calling it and then checking the output. And I even have a little conditional macOS stuff. Anyway, this is built. So what I was going to do is K1 optimize build dot, and then we're going to copy. We're just going to install K1 bindgen to our actual K1 installed there. So now I can say which K1 bindgen, and it's just installed there. And now if I go back over to the other project for HTTP stuff, and I guess looking at this, I should probably show you all the tabs. Yep, like that, because that's now relevant. We now can just call K1 bindgen. So let's try it. So what this will do, call the bindings generator on libs http.h, the file we just built and copied here. Well, we didn't build that one. And name it. The output will be that. The name of the module will be this. Actually, I was going to fix something. There's a command line option for -n libname, and it doesn't seem to be working. Libname. When it spits out the first namespace, I feel like it doesn't. Yeah, ns libname, that should be right. Okay, let's try it again. Okay, and it doesn't find student. I bet this is different. I don't quite know how to point Clang to the right system stuff on Mac so that we don't get weird stuff like this. Like obviously it should be able to find student. So what I like to do is just open a C file. And then find out where student is on this machine. Looks like it's here. Oh, because we have Xcode installed. So this would be our include-dir. So we'll copy that. And then, unfortunately, we'll just have to update that to point the right place, and we see no errors. And then we can just see if we have an http.k1, which we do. And here it is. So let's look. We have a bunch of garbage that I want to teach the bindings generator to ignore from student. And then we get to the good stuff. http internal. So this is the main struct for the parser. And the internal one actually is the external one. So if we look, and let's figure out why we don't have colors. Here we go. We're back. And now it's NSLHTTP instead of NSLib. All right. So what do we have in here? It looks like a parser. Index, span pause, span callback 0, error, reason, error position, data. That's our data. We're going to put stuff in here. Content length, type, method. So some HTTP stuff. The stuff that like unconditionally has to be in the message, I think, is in here. And the rest of it doesn't store. We have to store it via callbacks. So we'll see that in a sec. And settings. Pointer. So that's a big old struct. Hopefully we have everything programmed right so that it's the exact same size and alignment as it as it is in the compiled static lib, or everything will break. And then internal init, internal execute. We could skip generating these. Yeah, let's show off the bindings generator. So just file, we can come down here, -exclude LLHTTP internal init, and maybe we'll exclude execute. I wonder why those are in API.h. Maybe they aren't and we're recursing to them, you know? But let's do this again. Now let's reload the file. And those functions are gone. Nice. Here's the error enum. So we get a nice K1 either with every tag explicitly provided. These damn type aliases because of how C works with type defs. You have like what this is the enum you would write enum LLHTTP erno, right? Enum LLHTTP erno in C, or the type def is to LLHTTP erno T, which points to that. I think we could do something more clever here where we only keep one of them because everyone ends up just using the type. But here we are. Here's some flags. Looks like we correctly grabbed the bit flags. You see there's one missing here. Lenient flags. And that's about as much as I know about this library. Here's the methods. There's a lot more methods. Did y'all know there's a make calendar HTTP method? There's play and pause. No way. Subscribe. And then here are the response codes we all know and love, including good old Teapot. Enhance your calm. I didn't know about that one. Oh my gosh, it is 420. Guys. All right. A data callback takes the parser and byte pointer and length. And a regular callback just gives you the parser. The settings we have available to us are just 100 callbacks. And I mean that literally. Every single one of these is a callback. And this is the only thing. So the generated file is not currently compiling because there's some weirdness with out of order type definitions with aliases, and basically We see this struct here, and then we see that it uses this function type, and we spit them out, but we haven't like baked this one yet. So what I have to do is I have to move this alias down to here, and then we're fine. So something to fix in the type declaration pass. That's the only manual edit right now, and we should be compiling. So with this file in the root, and just to prove it, we'll do asdif, and then we'll do k1 check dot. We only have asdif. We remove that and recompile. Everything with lib slash needs to be http slash. And what else? Okay, except that one. We got a couple never used parameters, and yeah, we're type checking. And let's see if we can build. We can build. Let's see if we can run. And we can. So the hello world I've written so far, we're just parsing a string, by the way. There's no networking going on. LLHTTP is just a parser. But so because of the streaming nature of HTTP, what happens is, it probably wouldn't happen just like this, because this is like a unrealistic chunk, but we're going to be getting chunks from our socket, or when we read from our connection in using libev when we get there, and then we're going to be able to pass them along to HTTP, and we're going to have just little chunks here. So say we have get index ht and then HTML, and we call parse twice. We registered a couple callbacks here. So we have on each URL part, we get a part. We're printing what we get, and then we're putting it in our request state. So this is the URL as we've seen so far. And then handle message on complete, we have complete. So we have our complete URL, and then we have each part callback, where we get a few characters. So the second call only has 2 characters of the URL, and we look here, and that is true. So I'm pretty happy with that. And this is really ugly. Updating a struct, a couple members of a struct that we already have initialized kind of stinks. I have a number of nice things, but like I don't quite have something to deal with this scenario, except maybe for the patch, which I don't even remember the syntax for. So if I come in here, there's like a struct update. Let's look in Typer. So it's patch struct. Is it patching? Yeah, I call it patch struct. Okay. So it's a built-in function call lookalike if you call with. Isn't it? It must be a really good name if I forgot it. So it would be .with. So we have our settings here that we just initialized, and now we're going to do settings.with. And what's interesting is, why did we even need to call in it, right? Because we just looked at settings. We set all our own callbacks. So what is it initializing? Like, what do we think? I thought I had a browser window open. Let's do a new one. It sets all callback pointers to 0. Does it do anything else? Show me the source code, right? Wait, settings init. I know this one. Ah, I knew it. All it does is 0 the settings. So we could instead do this. And if we did that, maybe the LSP would crash. What's going on with that? The len is 1, but the index is 1. Well, we have some kind of bug. Okay. Fork in the road. Do we fix the language bug and then change this to be a settings.width so that it looks like this? Or do we try to get libuv set up and bind to a port and serve a request? So this is the built-in syntax that K1 has on every struct. And really what we could write, oh no, we need a pointer to settings, so this is fine. But we could do it all in one line by doing 0.width, right? But it's fine. Zeroed works. Still doesn't crash. Whoops. Still doesn't crash. Huh. Let's bring it all back. Still not crashing. Yeah, take it slow and fix the language. I agree. As you can probably tell. So why can't we repro that? We were uninit. Then we were zeroed. Haven't changed anything since then. Let's try and get it to happen again. It definitely happened in both. It happened when running from the command line and caused an LSP crash. So it's not a LSP state thing. I don't know. I have a feeling that this is the program exactly as it was when it crashed. Even if we like reset this all the way back, yeah. For victory, Russia, says heart. Heart back. We're trying to reproduce a crash. A compiler crash. But I can't do it. Oh, okay, settings.width with empty. That narrows it down dramatically. Ready? Let's go. It's literally right here. No, Rust's LSP is crashing on me. Right, maybe type text per parsed. Base dot value. So this is a bunch of early returns. So handle built-in function call lookalikes. Hopefully that tells you what's going on. These are things that look like function calls, but just aren't at all, like return, break, and this struct with thing, continue. Wait, I didn't think I had continue. Oh, I only said you can't do it in a defer. You can't do it at all, so why bother? Right F and right length. Okay. And strength. Okay. I don't think that's worth a test. Well, regression test, but I don't need a test for that. By just falling through instead of failing, what it's going to happen is if there's actually a method called with that takes 0 arguments, it's going to work just fine. We're basically just not intercepting this call to treat it like a built-in. Hello, what's going on? We just fixed a tiny bug. Nope, still crash. All right. Go ahead and do that. Relic 4x, what brings you here? Also for Victory Russia, what brings you here? Man, this thing is slow. Oh. Why is it still crashing? like, I'm pretty sure that that's gonna be updated. Yeah, 1 minute ago. Still crashing. Let's fix this and then see. Yep, that fixes it. So it's when it has 0 args. What? Oh! Hello. All right. This is the first argument. This is the second argument, right? So we're calling patch struct. Index is 1, but the length is 1. Where does it even grab the second? Yeah, it grabs it right here. So let's not even call patch struct. If let's revert this, and then we'll just say and has to be 2 parameters for us to detect this case. And it works with width as well. I love the look of K1, by the way. Thank you. Honestly, this is as ugly as it gets because we're like interacting with really low level C libraries. I think it's going to get a lot prettier once we can kind of like go up a bit, you know, but it has to be good at both. Nice, thank you. I feel like the aesthetic's kind of getting there, finding its own. It's been looking good with the purple theme. Let me switch it. The old purple theme. Although these strings should be green. And Capuchin. All right, let's see if we fixed. What do you like most about the language? The look? You mean literally the sort of the feel, or the kind of focus or feature set? You like the idea of traits in C? Me too. Let's look at the traits we have. Ability, grep-t, K1, ability. Let's just go to built-in. Yeah, so we have enum and some for enums and product types that give you some nice, like, to get the name of sums and enums. We have equals. Can't do without the equals type class or trait. Writer is amazing. It's been awesome being able to just implement writer on different types. Print is just, something that can put itself into a writer. This has been glorious. Show is kind of like toString. I haven't kept up to date on Zig. Yeah, all the vtables. I know. I don't really understand like these languages like Zig and Odin. Well, okay, Zig is pretty ambitious. Odin is not very ambitious, but like why they draw the line on like, I'm not going to implement. Maybe they just don't know. Like, inheritance is bad, so they're not going to do that. And but maybe they just don't have experience in FP and don't know how good type classes are for like exactly right-sized polymorphism and abstractions. And then the fact that you can so easily move them to runtime with dynamic trait objects and like do the vtable thing. Let the compiler do that for you. It's really, really good. Here's all these. Try. We have a .try, which is the same as the Rust question mark. And this is, kind of nice. The way try works is you can only implement it once, and the implementation brings the T and E type. Iterator, iterable. Those are the main ones. These are what power the for loop in the language, which I think is important. So it's extensible, right? Anyone can implement iterator. And there's actually only one. That's not true. There's 4 things you have to implement. Anyway. Let's see. Our bug is fixed. Method with does not exist on type. Boom. And we're back. Let's run. Success. Right. This produces a new settings. I thought I did. Did I do a mutate one? Hang on. .with. Idents with. Bear with me. Compile patch struct. My struct with. Yeah. I was gonna do a mutable one too, which would be like .update. Because we need to produce an address to a settings here, not just a value. And of course we could do this and even shadow it, and then that works great. So we just throw away, we throw away the old settings. It's a little bit meh. And then this is totally not kosher, but because we know that all init does is memset to 0, we could write this, right? And then this could be before the parser because it doesn't depend on it. And that's kind of a nice couple lines of code. Oh, we don't have to pass that either. Juicy. Now, I'm not actually going to do it this way because they reserve the right to change what settings init does, and you're supposed to call it. So we'll leave it. We'll go ahead and 0 our settings as well, though, to start with, because that's just a little bit safer. We won't 0 the parser though. We'll let them handle it. I don't need this. I can just write this. So that's beautiful. This sucks, having to write it like this. This needs to probably just become this, or maybe this. I just haven't implemented it. Value assignment destination must be plain variable expression. I haven't done the L value thing yet for struct members because it's a little bit complicated. Maybe we should try libuv. Let's generate bindings for libuv. I work on embedded and mostly use C and Rust for backends. K1 seems like it would be kind of nice on embedded. Yeah, unfortunately I don't. I've hard coded 64-bit pointers, or 64-bit word size, and like haven't taken too much care to be super portable. But if that became the use case, it'd be pretty easy to undo that. I was just being a little lazy. There's nothing like the language depends on. Nothing in the language that depends on that. This took me to GitHub. Let's do it. I think I want to clone it. I was having better luck earlier in some, maybe user guide. Yeah, here we go. Okay. What do you want me to do? Automake. All right, I don't know what that is. Maybe auto tools? A tool. Okay, glib tool eyes. Help. Lib tool. But of course. Here we go. All right, success. Configure and then make. What can you learn about my system? I bet the Rust stuff is really nice for like all the features that you get, and also hella annoying because it's Rust. And then I bet C is great because it's out of your way, but like super dangerous, and I don't know. That would be my guess. At the two choices you have at your disposal. I mean, Zig might be a decent choice. I don't know if it's there yet, like maturity wise, but it would be a lot less in your way. Maybe hair. I don't know if hair is there either. Okay, we built some stuff. Where'd you put it? Bunch of LO files. I've never even seen that before. I guess I could have run make help. Okay. Right, didn't it say to run make help? Am I crazy? Oh, this is in the docs subdirectory. Okay, I don't care about that. So okay. All right, I'll read it. The makefile was generated by the makefile.am, which is a little bit crazy. Precious. I don't know what that means. Okay. I know what phony means. I don't know what precious means. All right, show me mostly clean. Maintainer clean. Install info. Dist. Should we try running the tests? I just don't know about install. Because I just want the library. Okay, I'm just gonna, let's see. Yeah, I know I have it on my system, Jason. I want the files in the actual K1 project because of a few reasons. But you're right. I could probably just like -luv and it would find it. We could look at what's there. Like would it be under opt lib libuv? Yeah. Okay. Let's go in here and look around. Can I tree? So, oh yeah, this is what we saw in include. And then lib, like lib is what I'm missing. All I want is libuv.a really. I guess I do need the headers. And I need to know the structure because I need to bind gen, but yeah. This is good to know. So if we split and then libv.la, there is no lib. Let me check because I ran a different query too. The LO files. libtool uses them. I guess I should learn more about libtool. That's really what's missing. The corresponding real object files are stored in a hidden .libs directory. Okay. Okay, I see. Sure. That makes sense. Where are the goods? The title. The title, like you're a 5-year-old, building an HTTP server in my programming language. Well, we want to write a program that can respond to web requests so it could run a website or a web app. And we want to do it in a programming language that we made from scratch because we're insane. .libs. Oh my gosh, they're in there. They're in .libs. Oh, that's great. And we had one, I had one doing it the other day, but it was shit. It was using kind of a fake bad HTTP server. So it now we're using the HTTP parser and the async IO event loop that Node.js use. Yeah, maybe I should have used CMake. I used the libtool. Oh no. Right, I know. LA. To install it. I don't want to install it. Well, maybe I can install it to, let's see. Make file, install the real make file, please. What? Why wouldn't that one come up? How do I decide where I want it installed? This is insane. I just... Oh my gosh, I don't like this very much. I kind of want to like install it to the K1 project in the proper way, but is there a CMake? There is CMake. Maybe I should use CMake. Yeah, part of configure. I need to update K1 to look for libraries in this structure instead of how it does now. It just wants everything in libs, which is kind of neat, but let's still do it. Maybe it's not too late. What do I need to do? extra terminal can close. No. All right. I don't know. Remember to run libtool -- finish. But it's not even where I installed anything. Oh, I don't care. I don't want to mess with any of this system install directory stuff. Like, I just want it all self-contained. Wait. Oh, I didn't put it in dog food. So now it's just in K1 in just K1 HTTP. That's not what I wanted. That's what I wanted. Okay. And I'm going to copy this one out, get it into here. And what else is in here that we might want? Yeah, we can copy the symlink to. This has been a bit of a mess today. This is fine. We've got the static lib, so that should be enough. Back to K1. Okay, we ask for libuv. Let's just see if we can build. libuv. Oh, I'm silly. Because it's got... Okay, yeah, it is. It is just UV. And we linked with libuv. All right. Do we dare do bindgen? I don't want to do bindgen yet. What I want to do is just hello world. Okay. So UV loop init, UV run. Let's do this. We'll go libuv manual.k1. Okay. And this libuv. And now what we're going to do is we're going to open the header. I'm going to find UV loop T. Oh. Okay, I already don't really want to manually map this one. Let's do it because we'll think about the type while we map it. All right. This is the event loop itself. Okay. Use this for whatever. We get to use it for whatever we want. So the way we'd write this in K1 is data putter for void star. Okay. Loop reference counting. Unsigned int is a U32. And we got a UV double underscore Q, handle Q. All we were gonna do there is remove the struct qualifier. And then we have a union. We don't have raw unions in K1, so here's the thing. It's really a word sized, right? Because it puts a void star in here and then it's the unsigned int. We're not gonna be able to access it, but hopefully we don't have to. So what we'll do is we'll make sure we do an equivalently sized thing. BindGen might actually handle this union correctly because just to be ABI compatible, all I really need to do is have something with an 8 byte alignment and an 8 byte size. So we'll just do active rex pointer. And that goes in int registers too, so it's completely fine. We'll leave a comment in our temporary manual bindings, because that's just what we're doing right now. Okay, internal storage for future extensions without changing the size, I guess. Void pointer. A pointer is infinite. Internal flag to signal loop stop, right? If someone's called stop. Stop flag. And that's a cint, so that is an I32. We could also say cint if we wanted. UV loop private fields. Oh, fuck. Oh my God. No, 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 no. No. Oh, platform loop. There's more. Okay, this platform doesn't have any loop fields, at least, for us. This is why we have a bindings generator. We could literally point it at just this struct and it'd be worth it. Flags, backend FD. Monitors and FDs. A queue. It's funny, as soon as I have one, I want to do it by hand. Ooh, we have it to do. From Benordwis, remove in libv2. We're done with this. Once libv2 is out, we're not going to have to deal with this damn void async unused. It used to be something that was used, right? And they left it here because it was a pointer. Watchers, a timer heap with nelts in it, number of elements. I've never seen count as nelts. Signal pipe FD to pipe with an input output side. Okay. The thing is, we don't handle unions well. So how many unions are in this file? Only 2. And one of them is just, okay, we can fix those by hand. All right, we'll do the bindings generator. It's just that that's no walk in the park either. So, but let's do it. Bindgen libuv. K1 bindgen. We're gonna call it. Where is the file? The root, the source root. It's actually in libs. It'll be v include. It's whatever we just had open. uv.h. That's easy enough. I guess it's really uv.k1, isn't it? We could kind of do it either way, right? Dash in. I kind of like uv. All right, we're doing it. And then we need another clang arg, look, because we are compiling this from this folder. And then we're going to run uv.h. We're going to look, clang is going to open uv.h, and it's going to see all these includes, right, as it tries. Yes, this one. To include the other things, right? UV slash. These UV slashes are by paths, right? So we need to put the directory that uv.h is in. Basically, we need to put this include dir also on clang's include path. Clang arg I like that. Oh no. Oh, it's an XX macro. Okay. These things are cool. I guess I don't have to worry about it because it's just going to get expanded and libclang will handle it for me. We ready? How many errors? Error.h not found with angled include. Stdio.h not found. All right, so this is where we just open a C file. And find where it is. So why? Isn't that the path we're giving it? No. It's not at all. Why doesn't clang just... It's because I'm using my... Yeah, I don't... The reason clang doesn't find the system stuff by default is because if we go to the bindgen project, we're linking with our own installed LLVM, so our own clang, I believe. So maybe that's the problem, and we need to like build K1 bindgen to use the system clang. But I've been fine using this one and just pointing it at the system stuff. Okay, that was it. Do we still need this? Because I would like to not have that. Yeah, I like the version that doesn't spit out all those errors. All right, uv.k1. Oh, I wrote this today, by the way. Sometime this week. Write entire, yeah. We didn't have a way to write out files, by the way, so that's why I was spitting to standard out. But now BindGen writes out to files, and this is how it looks in the standard library. So we take in a string, a length string, we convert it to a C string using the temporary allocator. So we don't have to worry about freeing it. And fopen, we have a macro for C literals. So this puts a null terminator at the end of the string literal and gives us just the pointer to it. Here's our macro. We open a file for write. We defer the fclose, so that's going to run down here, or if we crash, it's going to run right here. So that's neat. Actually, to test defer, what I should do is spit out a bunch of like info diagnostics everywhere that we insert the deferred code, and like include the code that we're inserting so that I can just like visually test it as I start to use it. Then we call fwrite on the file contents, the length. We check if it failed. We're not worrying about returning a result from this yet because I'm just not sure if I want to like monadify like result some type fi the standard library or not. So I'm just kind of leaving it like we're just crashing on any error. Just don't know what I want the error handling idioms to be because those are kind of forced on everyone. I guess crashing is more forcing because if I returned an option, then at least people could then decide to crash or move on, but you know what I mean. This is what the macro expands to, and the LSP tells us that. Okay, this has been a brief interruption. There's write entire file. Do we dare? Here's libuv. It's 12,000 lines. I have a feeling I'm not going to like it as much as LLHTTP, which was 449 lines. uv.k1. $157 BindGen errors. This is coming from the system. Oh, let's turn off system. Yeah, this is just like the whole... Yeah, this is just all of the whole system. We do this. We just didn't even need it for LLHTTP, which is cool. Wait, no, system's off by default. Dash system is not equal to true. So skip system defins is going to be true. Oh no. So that means this is all coming in some other way. Yeah, this is all the stuff like... Maybe we can skip down to the bottom to get into the UV stuff. Yep, it starts on line 1425. This is also a bug. Where's a function? Everything, we flag everything as being inside libuv, which it obviously is not, like printf. So yeah, BindGen is just assuming that it's only going to emit definitions from the module we're compiling, the library we're compiling, which definitely is not happening. We're getting the whole system here. Let me go up through the errors. Union decal. How many of them are about unions? An incomplete array on UVFS right. Oh, that's an incomplete array. That's just pointer, yeah? Let's support that. Let's just do a pointer, right? I think it's going to be a pointer to that type. So where's reference? Where's pointer? Pointer, here. Right. So we'll call this a float. A floats array. That's an incomplete array. And we should just do a float pointer. Let's see, let's just update the output that we hope to get. That's what we hope to get. Oh, I never did it. That's what I want. Right, I changed those. Now it matches exactly. But we should write it after. We should write it after. Okay. Now it does match exactly, and that's what we get. And if we broke bindgen, how? Char? Let's just break bindgen. It doesn't match. We reload. It's still not F33 because we do the assert before we write the file. That's fine. I know it's fixed. Okay, so now there's like a command I keep doing. This is becoming like a just file speed run, I guess. Some sort of just. This is install, and we're just gonna do k1 optimize b dot, and then cp out bindgen to home. And then for some reason, I need to remove binaries before I put them somewhere, or they immediately exit, like the OS kills them. I don't know. So now we can just install, and that's going to be the new bindgen. And now, incomplete array, line 1495. Bindgen libuv. And I go to this line. Maybe it would help if I was actually in the K1. At least that's fixed. Only 141 errors left. But how many of them say union? Can I do error and not union? 24 are union decals. And then unions aren't. 25 are that unions aren't supported yet. What are the other errors? Unsupported union. Okay. Okay, it's pretty much all unions. I think we're going to add unions to K1 next. Oh, float 16, sure. I mean, this is also generating the entire, basically every header on my system. Block pointer. Holy. What is a libclang block pointer? What does it mean? Objective-C. Yeah, right. I thought it was things like that. We don't. I don't think we need to support those. Maybe we do. Okay. I'm gonna do add two things to K1 to help with C interop. We're gonna add union, but we're also just gonna add like an opaque type where, so we say array, right? So here's an array of 8 things. We're gonna have opaque, I think. I might just do this, and then it's the size, and the alignment. And then that'll help us express a lot of things, even if we don't have the type for it. And then I guess, yeah, we'll also add union. And it's gonna look, because we just say either and then variant, so we'll just say union and then name type, exactly the same as, it'll be like a struct, I guess, in there, yeah. Well, I think we took the wrong path. William, I think we should have, well, okay, no, that struct had like 100 members. So maybe not. I was gonna say we should have just manually bound the struct to get an event loop running, but maybe not. What I really need to do is fix bindgen to not spit out all these system definitions. So that's probably the most important thing to do next. I kind of want like an info. Is this just failing us? This is what I want to know. Why aren't you printing? Where's my output? Hello? It's not printing. What did I do wrong? Delete uv.k1, run it again. It's so fast. uv.k1 is back. Created this minute. Where's the output? Hello? I don't have it piped. Yeah, it can print. What's up? Two minutes ago. All right, what do we think? We're clearly printing on every visit. We even have this print here, which we haven't been seeing. So it's like we're not, it's not printing the options either. Something very funny going on here. It's not something to do with how just works. Yeah. Where's my output? What in the hell? It doesn't even print that. Exits with code 0. Well, I'm at a loss. What about the test? He prints all sorts of good stuff. Let's generate something else. Libclang, sure. This did change names. I knew it was doing the system stuff because I remembered this MB state struct from KQ. All right, I don't know. I don't know why it prints plenty of things when I run it from here, but then when I run it, it's because I'm passing an output file. So like all of these are piping. It shouldn't matter. If I get rid of the output line, it's gonna, okay. It like can't output. Because without an out path, which I just removed, it should have printed. Yep, it should have printed the whole output and it didn't. Oh well. Why can this process not print the standard out? No dice. What? I mean, what? Fun main. Krillin, I am here. Crash. Like, what is happening? Okay. But it doesn't print I am here. I don't know. K1 bindgen cannot print. The backtrace prints. Oh, it prints the lines. Right? Yep. Something really weird going on. We get the new lines. Almost like we're taking this path, right? Well, we'll figure that out next time. I'm about spent. Okay. We'll leave it in this state. It's working great. Here's libuv. We don't know why we can't print, but that's okay. Because we have progress. We just need unions and to ignore the system definitions. It'd be nice to be able to print again. Let's just run the tests of the compiler, make sure everything's still passing before I log off. Thanks for tuning in. A little bit of a womp womp sesh, but that's how it goes sometimes. All about that grind. Learned more than we think. Got libuv built. Got the headers and libraries in the project. We're linking with it successfully. We just need some bindings. That's not bad. Bindings generator can't fucking print a standard out, and we don't know why. All the tests pass. I mean, there's a static print and module info. I am at a loss. All right, till next time.